Namaskara. Welcome to Curious Minds podcast, the show where we take the world apart to see how it works. I'm your host, Manjunath. I want you to picture a moment we have all suffered through. You are cruising down the motorway. Maybe it's the M25, maybe it's Interstate 5, the sun is out, the playlist is good, and you are doing a steady 70 miles per hour. Then, without warning, brake lights. Red flare, you slam on the brakes, your heart jumps, and then you crawl. 5 miles per hour, then 0, then 5. You creep forward for 20 agonizing minutes, neck craning, expecting to see a twisted wreck or a police cordon. But when you finally reach the front of the line, there is nothing. No crash, no construction, no cow sitting in the lane. The road just opens up. You were fighting a ghost. This is the phantom jam. And believe it or not, there is a mathematical reason it happened. Today, we are going to look under the hood of the most frustrating part of modern life. We'll travel from the orderly freeways of Melbourne to the chaotic streets of my own city, Bangalore, to answer one question. Why does the fastest way home often require driving slower? But remember, I'm an engineer at heart, not a wizard. The math is real, but your mileage may vary. Let's start with the big idea. We tend to think of traffic as a collection of individual cars, machines of steel and glass driven by people with places to be. But physics disagrees. To a physicist, traffic isn't a collection of solids, it is a fluid. Think of a highway like a pipe, and the cars like water molecules rushing through it. When the density is low, the water flows fast. That is laminar flow. Smooth. But when the density gets too high, the flow becomes turbulent. And here is where the phantom jam begins. Imagine a driver 2 miles ahead of you. Let's call him Dave. Dave gets a bit nervous and taps his brakes, just for 1 second. That red light flashes. The driver behind Dave sees it, panics slightly, and brakes for 2 seconds. The driver behind them brakes for 3. That tiny tap Dave made ripples backward through the pack, amplified by every nervous driver, growing in intensity like a tsunami in reverse. By the time that ripple hits you, 2 miles back, it's no longer a tap. It's a full stop. That is the shockwave. Researchers in Japan proved that these waves can appear even with zero accidents purely due to density, a discovery later modeled by mathematicians at MIT. So, how do we stop the wave? To understand the solution, we have to look at rice. Yes, rice. Imagine you have a bag of rice and a kitchen funnel. If you dump the entire bag into the funnel at once, what happens? It clogs. Nothing moves. That is turbulent flow. But if you pour the rice slowly, giving the grains space, they rush through the funnel instantly. That is the paradox of traffic physics. To go fast, the fluid must be less dense. And here is the fundamental law of traffic flow. To reach quicker, you must go slower. You have to put fewer cars into the funnel to get more cars out the other side. It sounds crazy, right? But cities around the world are proving it works. Let's travel to Melbourne, Australia. Before the math stepped in, the freeway on-ramps were a war zone. Imagine the scene. Thousands of cars trying to merge at once. It was pure stress. Drivers fighting for gaps, sudden braking, fenders crunching. The waiting times were climbing and the incident rate was spiking because of the rice clog effect. The road capacity was maxed out, not because of space, but because of friction. So the engineers introduced a gatekeeper. They installed ramp metering signals. Those annoying traffic lights at the on-ramp that only let one car go every few seconds. Now, if you are sitting at that light, you are fuming. You are thinking, why am I waiting? The road is right there. But here is the math. By holding you back, the system prevents the funnel from clogging. It keeps the density on the freeway just low enough to maintain flow. The data is incredible. On the M1 Monash freeway, these smart systems increased traffic throughput by nearly 30% during peak hours. The numbers proved that waiting a few seconds on the ramp saves you massive time on the drive. Now let's hop across the Pacific to Seattle in United States. Here the problem wasn't the on-ramp, it was the speed trap. Drivers would speed down Interstate 5, hit a congested zone and slam on their brakes. Bam! Shockwave created, so Seattle introduced active traffic management. You've seen these, the overhead electronic signs that change numbers. Here is the genius part. The signs drop the speed limit miles before you even see the traffic jam. It feels counterintuitive. Why slow down when the road looks clear? It's called harmonic damping. By forcing everyone to slow down together before the crunch, the system dissolves the shock wave before it can even form. Instead of a stop-and-go crash, you get a slow, steady river. The result? The Washington State Department of Transportation found that these systems significantly reduced collisions and increased capacity, turning a wall of traffic into a smooth stream. But those are the easy levels. Now, we go to the boss level. We are going to the city where I've spent more hours staring at brake lights than I care to admit. My home, Bengaluru. In the West, traffic math relies on the standard model. It assumes cars are uniform particles, pretty much the same size, moving in straight lines, staying in lanes. In Bengaluru, forget it. Here, traffic is a non-Newtonian fluid. In one lane, you have a Volvo bus, a solid. Next to it, a motorbike, a liquid that fills every gap. And in the middle, a cow, the ultimate obstacle. Lane discipline? Boss, it is just a suggestion only. The standard fluid equations break down completely because the particles change shape, speed, and direction randomly. It is chaos. But it is organized chaos. So how do you solve that? Math that worked in other parts of the world may not work here, but AI might. Google is testing a project called Greenlight in cities like Bengaluru. Instead of trying to change driver behavior, let's be honest, is impossible. They optimize the flow. They use massive amounts of maps data to retime traffic lights, creating green waves that account for the chaos. Their early data is staggering, showing a potential to reduce stops by up to 30%. Then there is the new ITMS, the Intelligent Traffic Management System used by our traffic police. It uses cameras to detect violations and congestion automatically. But until the AI is perfect, we rely on our own timing. You know, we Indians have a special relationship with time. IST is called Indian Stretchable Time. If I tell you I am 5 minutes away, you know that actually means I have not left the house itself. Why? Because I am factoring in the non-Newtonian variables. Jokes apart, the Bangalore traffic issue is not solved yet. Honestly, if we can solve the fluid dynamics of a Bengaluru junction, we can probably solve traffic anywhere. We've talked about fluids, rice, and robots. But there is one final variable in this equation. The most unpredictable one? You and me. This brings us to the selfish driver. We have all done it. You are in a slow lane, you see a gap in the next lane, and you swerve into it. You gain maybe 50 feet. But let's look at the game theory of that move. It is often linked to the Nash equilibrium, where individual winning strategies lead to a losing outcome for the group. When you cut into that lane, you force the driver behind you to tap their brakes. That tap starts a new shock wave. So, while you gained 2 seconds, you just created a delay for 500 people behind you. And then, someone cuts in front of you and you have to brake. The truth is, traffic is a cooperative game, but we play it like a competitive one. The optimal strategy for the individual weaving to get ahead actually destroys the strategy for the group. There is a saying, when everybody is rushing, nobody is on time. So, what is the takeaway? The next time you are stuck in the phantom jam, fighting the ghosts of physics, don't be the shockwave. The math is clear. The only way to beat the jam is to pick a lane and stay in it. It requires patience. It requires trust. But it turns out the fastest way forward is to move together. I'm Manjunath. Thank you for riding shotgun with me today. Next time you see a gap in traffic, maybe let someone in. Stay curious, stay kind, and please, drive safely. Namaskara.